We have one question from the chapter Maxima Minima. The question says that prove that the volume of the largest cone that can be inscribed in a sphere of radius r is 8/27th the volume of a sphere. So let's say if I first draw a sphere, this being a sphere, and I'll draw a cone here. The cone with its circular base. Now this cone has to be placed inside. This cone has to be placed inside a sphere, and we have to maximize its volume. That means whatever is the maximum volume that can be possible. Okay. Now the dimensions, as we can see that this is the height of the cone, and considering this to be the center of the sphere, this is the radius of the sphere. And as for the question, it is given as r. So this is r, and even this is r. Let's say if I take A, B, C, and if this is O be the center, or let's say M is the point here, then this OA is also R. Right, and I'm going to take the radius of this radius of the cone as R. We don't need the slant height over here. Now, in a question of maxima minima, what do? We first find f dash x. From fx, we find f dash x. We equate with 0 to get the different points of extreme called the critical point. Then we find f double dash x. Second order derivative test is like this. We will see the sign of f double dash x at different points, say x1 and x2. If you get f double dash x sign is at x1, say greater than 0, we say it's a point of local minima. Otherwise, it is local maxima if you get the value of f double dash x as less than 0. Now we have drawn the figure, and now what we have to prove here is, we can see in the question, we have to prove that the volume of the cone is what? Volume of the cone is 1/3 pi r square h with its usual symbol here. And the volume, say V dash, I take as the volume of a sphere is 4/3 pi. As for the figure, the radius is capital R. So this is capital R cube. So in fact, what we have to prove is that V is equal to, that is the volume of the cone is 8/27. 8/27, the volume of this sphere. Right, this is what we need to prove. This is what we need to prove here. Yes, once we have analyzed what we have to prove and what is constant, well, radius of this sphere is given as constant. Yeah, one more thing that we have to figure out, that let's say what we have to minimize or maximize is the volume of the cone here, which I've taken V, which is 1/3 pi small r square h. Now we can see that we have two variables, and we need to convert these variable into single. So let's magnify this figure to understand this better. I'm going to consider this part, say OM as x. So what you can figure out that I can write the height in terms of x. The height of the cone is what? This plus this, that is OR, which is capital R, plus x. And I can also use this, this being the radius of the cone, I can obtain the relation as this x square, or maybe r square will be better. So the square of this, that is the base, is equal to the square of the hypotenuse minus the square of the perpendicular. So I've used this figure and obtained some relations so as to help us during substitution. And we have also obtained what we have to prove. And this is some relation with the constant. I can place it here. Now, some substitution is needed, as we have already decided that a substitution is here involved. So I can write V as 1/3 pi. I'm replacing this r square. this r square can be replaced with capital R square, which is a constant here, minus x square, the variable which I'm going to take it. And the height here, again, we have this height. We can replace this height also. This h from here can be replaced from here. So this h is what here? This h is capital R plus small h. This capital R plus x. That is the height. This is obtained here. Now we can see we have one variable and the others are constant. Then we'll find its derivative. So if I differentiate with respect to x, dv over dx is equal to pi by 3, which is a constant here. I'm going to apply the product rule. Derivative of this is what? Minus 2x, r being a constant. And this r plus x being copied, u dash v plus uv dash. This time, I'll find the derivative of this, which is 1. And this will be u dash v and uv dash. Now I can see that we find its first order derivative and we can find its second order because we'll be using for the second order derivative test. So here too, I'm taking pi by 3 as it is. Before simplification, I think we need to simplify before finding the second order derivative. So let's first simplify it. So this is dv by dx is equal to pi by 3. This is a plus, applying this a square minus b square, I can see this is r plus h into r minus h, and this is r plus h. So we can take r plus h, r plus x, sorry, is common. Then what we get here, minus 2x will be obtained from here. And what will be left? R minus x, because we have taken r plus x as common. So it will give you r minus x. So this is dv over dx finally should be pi by 3 times r plus x. And this is going to be r minus 3x. So we'll have found the first order derivative. Right. Then we'll find its second order derivative. So if I do so, this is d square v by dx square. Well, pi by 3, I'm taking it outside. Derivative of this is what? 1 derivative and r minus 3x. Applying the product rule. Plus this time r plus x going to be as it is. And its derivative is minus 3. So I can write minus 3 over here. We got its second order derivative. Yeah, I think we can do one more step of simplification. So it's going to be r minus 3x minus 3r minus 3x. And in this simplest form, it's going to be minus, right? It is minus 2r minus 6x. Further, I can take minus common and write these as positive. Clearly indicating that we are going to get a negative values for any positive value of capital R, which is positive, and any positive value of x here. So this will give you negative. That means we consider this to be maxima. Okay, now what we do in the next step, as we have done this step, we have done this. We have also find f double dash x. We are required to equate the f double dash x with 0. So let's see where I can do it. Let's place this below and equate the f dash x with 0. So when we equate f dash x, this is what the equation 1 I'm saying. dv by dx when equated with 0, I can simply say that, okay, let me write one. Pi by 3 over r plus x times r minus 3x equals 0. Equating this with 0, we'll get this r is equal to minus x. Clearly, this value should be discarded as we cannot have dimensions as negative. But when we equate this with 0, I get r is equal to 3x. So we got, and we'll show here that this is coming, right? For r is equal to 3x, placing r is equal to 3x will get negative, right? Placing here r is equal to 3x, that is 6x plus 6x, that is 12x, and x is positive. Therefore, we are getting less than 0, and we'll say the hence minima. Now, but we have one more thing to prove here. That is the to prove part is this. So now we have to prove this. What we have to prove here, let's say, I have already written V, which is the volume of this. We have to prove that 1 by 3 times we have to prove that volume of the cone, which is 1 by 3 times pi r square h is equal to 8 over 27, the volume of the sphere, which is 4 by 3 pi r cube. Now I'll use LHS and RHS to prove this. So for that, I'm now deleting this. We have used this figure. We have used this. Now from the LHS, we have 1 by 3 pi small r square h. So what I can see here that I'm writing all in terms of x and r. So r square, this r square from here is coming to be capital R square minus x square, and h from here is capital R plus small x, which is 1 by 3. And I'm going to replace this capital R. So it is 3x square, which is what? 3x square, 9 square, right? This is 9x square from here, minus x square, that is 8x square, times, this is what? 3x, right? 3x plus x, 4x. So we got this as 32x square. Oh, this is x cube, not x into x square is x cube over 3. This is what we get the LHS here. This is the LHS. Now I have to accommodate within the space only. I'm going to do the RHS. So this RHS is what? This is what our RHS. This is 8 over 27. And this is 8 over 27 into 4 over 3 pi cube of r cube, and r cube is what? 27. That is cube of this, right? 27x cube. Yeah, I can figure out this 27 get cancelled. 8 into 4 is 32. 32 pi, I missed pi here. And then x cube over 3. Now check here. We have this is equal to this. So LHS is equal to RHS. This is what we need to verify, that the volume of the cube is, volume of the cone is 8 by 27, the volume of the sphere.